Hello and sorry, welcome to my channel on classical physics. Today we will be dealing with a rotational motion problem. It's a fairly simple problem, but still fun to work with. So here we have a ball which is put on a rough surface with a velocity small v imparted to it in the positive x direction. Please try to understand that it is just the velocity which is imparted. There is no at this point we have the ball moving forward in the x direction with a velocity v and rolling as well, but in the opposite direction. So normally you would have the case of a rolling ball which is rolling forward with a velocity forwards, but here in this case we have a rolling backward situation as shown by the direction of the arrow here for omega. So we have a velocity v towards the positive x-axis, a reverse rolling, if I may say so, backwards with a frequency omega given by v by r, where r is the radius of this ball, and of course it's a rough surface. So what we are required to find out is as to what is the velocity of this ball at the instant when this ball stops rolling for the first time. So you can understand here that as the ball moves forward, we see that at this point of contact here we have a situation where this point of contact slides forward in the ground. If this is the ground here, this point of contact moves forward by virtue of this velocity v, and also because of the rolling motion. Normally you have a rolling motion in this direction, then this point moves backward, but here we have the point moving forward due to this rolling motion as well as due to the velocity. So there will be a net frictional force which will act backwards at this point, as denoted here by F. So in this situation the frictional force acts backward. What it does is twofold. One, it decelerates the ball in the positive x direction, so reduces this velocity. At the same time it reduces the angular velocity of the rolling motion here by imparting a torque in this direction. If the force of friction acts like this, there is a torque which will act through the center of this ball, which will reduce the speed, the angular speed omega for this ball. So these are the few things which will happen, and now let's get on to the numbers here. So there is a normal reaction force which acts on this ball at this point of contact, which will be given by n equal to mg, where m is the mass, of course. The force is balanced. There is no net force in the y-axis direction, so that is the first thing to happen. Then we have a torque which acts on this body, on this ball, which is given by F cross r, and because the angle is 90 degree between the force and the vector for r, so it is simply F into r, which is mu times n times r, mu mgr. So the torque at this, the torque which acts through the axis here is equal to mu mgr, and the moment of inertia for a sphere of radius r through its center is given by 2 by 5 mr square. So this is the moment of inertia here, and now we know that torque which acts on a body is given by dl by dt. So L here is the angular momentum. So if you will see here that the torque in this case is mu mgr, so dl by dt is equal to mu mgr. That is one thing. Now angular momentum is nothing here but L equal to I omega. So replacing L by I omega here in this equation, we get d L by dt is equal to d I omega by dt, which is I is a constant, it can come outside the differential, so I d omega by dt is equal to mu mgr. This is a very important point here. I d omega by dt is equal to mu mgr, and if we solve this, we'll get the value for d omega by dt, which is just delta omega by delta t, because it's a constant, and you know the time interval which it takes. And from here you can simply use the kinematic equation v equal to u minus at, substitute v for u, acceleration you would know, and that way you can come up with the final velocity as v dash equal to 3v by 5, as given here, v equal to 3v by 5. So this is the velocity which the ball would have at the point where it stops rolling. After the time, the action of torque will stop this ball's rolling motion. At that instant, the velocity forwards for this ball would be given by v dash equal to 3v by 5 here. So this is a relatively simple problem in rotational mechanics. Hope you got the concepts here. So till the next time, I'll come up with another good problem for you. Till then, you can practice these questions, and please feel free to write me over mail asking any solutions for any questions you might have, and all the best for your preparations. Thank you.